Hi friends, I think you must be enjoying the topic, text analysis, and you must have learnt a lot till now. So in the last lecture we talked about what is topic modeling in the one of the most important parts of text analysis, right. We discussed why topic modeling is important and how it is useful for researchers to understand what are the important topics that can be determined from a bunch of documents, right. Those documents could be maybe books, magazines, libraries, like for example journal libraries. So or you can see tweets, or anything that you can find out on the social media, what people are talking about on a particular topic. So you can get a pile of documents and then try to understand what are the most important topics, so which are being discussed around that particular, in the particular discussion, or that particular, you can say essential topic basically. So we can understand the theme or the topic that we are trying to find out, right. So from a, let us say there is a journal which has several articles, and we are trying to find out what are the most important themes on which the articles are surrounded, right. So that is what is topic modeling all about. Or for example, through the reviews, managers can understand what are the most important topics on which customers are discussing about that product, be it the quality of the product, be it the distribution of the product, the pricing of the product, or maybe the delivery, or anything, it could be that, right. And while understanding text analysis topic modeling, we introduced the topic and then we understood how it is a distribution of words, right. So we understood the topic is nothing but a distribution of words, and the most frequently used words are nothing but our main topics, okay. And where topic modeling is used, that we talked, and the topic modeling algorithms. So we talked about three basically algorithms. So which is, the first one was LDA, or Latent Dirichlet Allocation, right. Why it is called so, that also I had explained, because it follows a Dirichlet distribution, right. So because of that it is, this name comes, and this is a basically a probabilistic generative approach, okay. And then we talked about two other models after that, that is the NMF, right, and the BERT, right. So these three things that we discussed, and we understood how they can be used. So we also talked about the advantages and disadvantages in a matrix form. So where BERT is used, when NMF is applicable, where LDA is applicable. So all the things, the advantages and disadvantages we discussed, okay. So in today's class, what we are going to do is, now we are trying to have a hands-on exercise on LDA in the Jupyter lab, right. So what you will do is, now with me you will also start, you may open the Jupyter lab and you can start working with me, right. So let us begin the practical work and learn more about LDA, okay. So now we are getting into LDA. So let us begin. So we start with the very basic, the first step, that is the first line of code that we write is import pandas as PD. So now, by now you must have been experienced, right. So you have already learnt why we write PD for pandas. So and what it does, basically it imports the pandas library, which is used for working with the data, structured data like the CSV files and all, right. So the next is, we go to the next code is import numpy as MP, okay. Now what does the numpy library talk about? It is a library for numerical operations, often which is used alongside the pandas for data transformation, okay. Next we will go for the next code, which says import matplotlib.pyplot as PLT, okay. Now this code imports the pyplot module from matplotlib library, which is used for creating plots and charts to visualize the data. So whenever you want to see how your data is structured in a different formats like histogram or box plot or anything for that, a line plot, then this library helps you to do that, right. The next code is, we have written here, if you can read it, from sklearn dot feature underscore extraction. So this entire code you can see this, right. Now what is the use of this code? Now this code brings in the count vectorizer from sklearn, which transforms the text into a matrix of word counts. Now this is a standard processing step in text analysis, because we understand in the most important thing in text analysis or topic modeling is all about understanding the distribution of the words, okay. After this we go to the next code, which is as you can see here, which talks about importing the LDA library, right. So, latent Dirichlet allocation. Now, this is the one of the most important libraries, right, and as we have already learnt that this is a popular algorithm for topic modeling. So, what it does basically, it identifies the hidden topics in a collection of text. So, as you have already learnt that LDA uses co-occurrence methods of the co-occurrence of words approach. So, that is why LDA model is very useful, and that is why we need to import this library for conducting our topic modeling process. Okay. The next code, if you go to, is from word cloud, import word cloud. Now, I think you must have all done some or the other way word clouds, or you must have seen word clouds, right, because they are a very popular way, a very beautifully looking way of diagrammatic representation of your words. Now, the words which are most frequently occurring, they seem to be very large in size in comparison to the ones which are not coming frequently in the text. So, they will be shown in a smaller size. Okay. Now, this imports the word cloud class to generate word clouds, which visually display the most frequent words in a topic or data set, right, and size indicates the frequency, as I said just now. Okay. Now, what we will do after all the these codes, now we will load our Excel file. Okay. Now, the Excel file we will load, and which was processed comments, or we had used the file TA2 if you remember, right. So, now the code for that is df is equal to pd.read underscore excel, right. So, this code, if you read, just only thing is, if you have to use the TA2 file name here, right, because you remember we had given the TA2 file, as we had saved it as TA2 file, right. So, now what it will do, when we give this code, right, it will load the Excel file named TA2 into a pandas data frame called df. Okay. And this file is expected to contain a column called the processed comments among the other columns, right. So, you remember that. So, we had 3-4 columns, right. So, the original one, then the comments which were cleared of the words, like removing those unnecessary words like is, the and all, they were removed, and then you had the final comments, the processed comments. Okay. So, the entire study or the analysis will be based on this file now, right. So, this processed comments. Okay. The next code is df underscore filtered. Now, this command or this code selects the processed comments column and removes any rows from the comment which is missing, right. So, if there is the comment is missing in any row by chance, so which is, it is called NaN, or it is a null basically, right. So, that will be removed. Okay. The next code after that is this one, if you can see. Okay. df filtered is equal to df underscore filter, and the entire this code, right. Now, this removes the rows where processed comments might be an empty string or just spaces, right. So, any white space is there, so that also will be cleared. Okay. So, as you can see, str.strip, that removes leading trailing spaces. Okay. As type converts the string to a boolean, boolean condition, right. So, false if it is empty, true if it has something written in that, and this line keeps only the rows with meaningful text in the comment. So, finally, we will deal with those lines only which has meaningful comments, right. So, what it basically means? So, we are loading the data, keeping only those comments and cleaning it by removing the empty or missing ones, and preparing for the next analysis, which is our text topic modeling. Okay. Now, after you are done with it, now you go to the next code. Now, what is the next code? So, here if you can see, DTM is equal to vectorizer dot fit. So, this one, right, I am highlighting this. So, yes, this one, right. So, now what does this code say? This code applies the vectorizer to your cleaned comments, right, the processed ones which in your file, and transforms them into a document term matrix, DTM. Okay. So, a table where each row represents a document or a comment, and each column represents a word, right. So, this is what basically our whole purpose is, right, to find a document term matrix. Okay. Next, after this, we will go to the code feature underscore names, right, and this code retrieves the list of actual words right, that are in the document term matrix. So, it is basically the vocabulary that you are the words that are used after filtering. Okay. So, in short, if you want to understand, it is like you are converting your cleaned text data into a matrix of words, word counts, filtering out common and rare words and capturing the vocabulary for use in your topic modeling, right. We have given n underscore topics is equal to 5, right. So, basically here we are talking about maximum, that means 5 topics which we want to find out, right. But that is, you can also change it, it does not it is not that it is mandatory you have to keep always 5, but here we are generally the standard is we maintain 5, okay, because the more you increase the complexity also increases. So, when you say n underscore topics equal to 5, you are setting the number of topics you want the LDA model to find in your text data is identify 5 topics, that means. Okay. Then after that we go to the next code, which is this one, LDA underscore model. Now, if you see this model, right, now this what is basically does. Now, this code initializes the LDA model. Okay. So, n underscore components, this tells you how many topics to find, which is 5 here, right, and that random underscore state, if you can see, is equal to 42. What does it say? Now, this ensures the results are reproducible. So, the same input will give the same output every time. So, if you want to change, you may increase the number or something, right. If you want to do that, then it will give you a different output, otherwise it will give a similar output all the time. Okay. The next code is LDA underscore topics, this one, right. Now, here this trains the LDA model on the document term matrix. Now, already we have done enough what is document term matrix. So, we have learned that. So, now what it says is here the LDA model will train. Okay. Now, this result, the result that LDA topics comes up is a matrix where each row represents a document, which we have already stated, and each column is the probability that a document belongs to certain topic. So, we get the topic and the document, right. Now, basically just to understand what you are doing here is you are training a topic model on your comment data to discover 5 different topics, and you are getting a probability distribution of these topics for each comment. So, what is the probability distribution? That is what we are saying. No, it is a probabilistic generative model, right. If you go to the next code now, the next code it says for topic underscore IDX, right. Now, this one. So, by doing this, writing this code, basically you are looping through each topic found by the LDA model, right. Now, this LDA underscore model dot components, it contains the word distribution for each topic. So, that means what it does is basically tells you how important each word is in each topic. So, what is the importance of a word in each topic, that is what it is telling you, right. So, and it follows the index from 0 to 4 if there are 5 topics. So, and the topic is the array of word scores for the topic. So, 0, 1, 2, 3 and 4, right. So, 5 topics basically. The next code we go to is print, right. Now, what we are asking here? We are asking the computer to give us top 10 words and scores, right. So, it prints the current topic number and a heading, right. Now, after that, if you go to the top indices, top underscore indices, this code, right. So, this finds the indices of the top 10 words in the topic, that is the 10 words with the highest scores, which 10 words are getting the highest scores, that is what it will tell us. And that arg sort, now this command sorts the words by score. Okay. So, and from a highest to lowest. So, it follows a descending order. Okay. After that, you go to the next code. Now, the next code, what it is saying? For I in top underscore indices. Now, again, if you see, this loops through the top 10 word indices and prints each word with its importance score, right, rounded to up to 4 decimal places. So, what it does, it rounds off up to 4 decimal places. Okay. Okay. So, next is you go for word cloud now, right. So, in this what you are doing, it creates a dictionary with the top 10 words as keys and their scores as values, right. So, this is used to generate a word cloud that you must have seen so many times. So, this word cloud is generated with this. The next code says word cloud is equal to this one, right, up to the width and height is given to you. So, it initializes a word cloud with a white background and a specific size, because the color you have already given. So, these are changes you can make, it does not matter, right. So, you may not put white, you may put some other color also, but then the contrast and all things that you have to see, you have to have some basic artistic knowledge for that. So, width is 600, height is equal to 300, you can adjust all these things. The next code is word cloud generate, right. So, this generates the word cloud using the frequency of each top word. Okay. Now, go to the next code. So, the next code says plt plot dot figure, right. So, here it sets the figure size for the word cloud plot. Okay. The next code is plot dot im show. Okay. Now, it displays the word cloud image. So, if you give this, if you do not give this, it will not show you the image. If you give this code, write this code, then the word cloud image will be shown to you, will be visible to you. The next code is plot dot axis. Okay. So, this code hides the axis for a cleaner image only display. So, it will make it very clear for you to understand and read it, and even if you want to copy it also, you can take it. The next code is plot dot title. So, what is this? As everything is very clear, if you can see that codes are very clear. So, it says that you are adding a title showing the topic number, right. The next code talks about the layout basically. So, now this code ensures that spacing is neat and then the displays the word cloud for that topic. Otherwise, what will happen? It will look very untidy, no. So, that is why if you write this code, it gives you a very neat display. So, all this what you have done, right. Now, in short, we can understand that for each topic now we will get the printing, right. So, you see this is what we will see, topic 1, the 10 words and scores. So, the 10 words are here. So, world, people, progress, global, goal, don't, poverty, right, country, social, like. So, I think you should not get confused why it is showing poverty as TI and country as RI. That you, if you remember, we had already discussed that it goes to the root, the nearest root. Okay. So, that is the reason. And here the top words, the values are also given to you. World comes the top word, right, with 38, and the lowest is like, which is 18 point something, 97, which is almost 19, right. So, now you see the word cloud. So, this is how it will look. So, topic 1, so this is the topic 1, topic 2 again. So, topic 2 again it does. So, 5 topics we said, no, it can give us 5 topics. So, 3, 4 and 5. So, these 5 topics, and as according to these 5 topics the word cloud is shown to us. Okay. I think you can, if you look at these values also, you can make a understanding that, look at the differences, what, how they are different to each other. Okay. After we are done with all this, right, then we finally come to this code, which is for I in range. Now, this code, if you go to this code, now what does it give you? Now, for each topic, so that is the topic 1 to 5 that you just saw as in the form of word cloud also, you are adding a new column, right, that contains the probability score for that topic in each comment. So, if a comment is 80% topic 2 and 20% topic 5, those values will appear in the respective columns. So, that we have already seen, I believe, right. Now, coming to the next code, which is df filtered, right, underscore filtered. So, by doing this, giving this code, right, for each comment, this finds the index of the topic with the highest score. So, the most likely topic for that comment. Okay. So, this becomes the dominant topic column, right. So, dominant topic. Okay, fine. Now, what are we going to do after all this? So, now what we will do is we will go to our next line of action, which is to find out the top keywords. So, this code helps us to find the top 10 keywords from the topic, and that code which is written as ARG sort, right, it gets the top 10 words from highest to lowest. So, in a descending order, and this results in a list of keywords for each comment. Okay. After this, we go to the next code, which is df underscore filtered top keywords. Okay. So, what does this tell us? Now, this code will give us the list of keywords for each comment into a string. So, it will join the keywords in a string, like for example, health, wellness, natural, period, relief, herbs, hormones, balance. So, all these different keywords, it will join them in a string, into a string like, right, and this is added as a new column in the name of top underscore keywords. Okay. So, then we come to the final code, which is the save results, basically is to save the results. So, this is df underscore filtered. So, you can see this. Now, when you write this code, it saves the final data frame to a new Excel file, right, and this new Excel file will contain the original cleaned comments, the topic probability scores, the dominant topic for each comment, and the top keywords that define the dominant topic. So, let us download this, right, and let us download and see how it exactly looks. Okay, just a minute, because these computations are not so easy. So, they take little time. Okay. So, just have patience. Okay. So, we got it. So, sometimes technology ditches you. So, you need to have patience, have first of all conviction about your process that you have adopted, and then believe that you have done rightly, and then maybe the technology will also help you out after some time. So, as it has happened in our case also. So, you see, so this is all we have. So, the processed comments, right, in the first column A, and then we had the topic 1 score, topic 2 score, topic 3 score, topic 4 and topic 5 score, right. So, then we had the dominant topic. Now, dominant topic, for example, just go to one by one. So, let us go to one, the first one. So, dominant topic is 0, it is saying. What does it mean? Now, the first one, topic 1, right, because 0 means topic 1 means topic 2 and 4 means topic 5. So, you can understand from that. So, here from here we can find out which is the dominant topic, right. So, that you can also do visually, but that facility is already there. So, it is why should anybody do it. So, automatically the dominant topic will tell us which is the most important column in this 5, right. And after that we go to the top keywords. So, the top keywords are, for example, in the first case, world, people, progress, global, goal, don't, poverty, country, social, like. Okay. The second one, if you see, it is saying what? Now, the dominant topic is the fifth topic, and the keywords are thank, talk, better, world, make, place, goal, inform, nice, video. So, all this are giving you the top keywords, right. So, this is what we have in topic modeling. So, you can go through all the different process comments and understand it. You see which are the most important topics, the dominant topic and the top keywords. Okay. So, let us go back to our main file. Okay. So, with this I think we have done LDA, we have understood LDA, how to use LDA for topic modeling and how to make a word cloud also we have understood. So, you just what you have to do is follow the steps that I have done. In fact, you do not have to remember, the codes are already shared with you. So, just copy and paste and make the slight changes wherever necessary as per your need and run it. I think you will get a very good hands on experience. The more you practice, the more you will learn and you will get expertise in that, right. So, I think you are today richer with a new knowledge of how to use LDA for your text analysis and topic modeling. So, with this I will wind up today's lecture. In the next lecture, we will talk about how to have a work on the NMF method, right. So, that we will do in the next class. Okay. So, till then, take care and thank you very much.